Hello friends, welcome to my channel. So we are here to start a series of videos to address the stock buy and sell problems in Leetcode. So here our plan is to solve stock buy and stock sell problems in a uniform manner with the below order. So we are going to first look at problem 188, and then we are going to look at problems 121, 122, 123, 309, 714. So in this video, we're going to explain the general case using Leetcode problem 188, and then we're going to solve others in the follow-up videos. So here, actually, all these problems are characterized by the following things. The first is the allowed number of transactions, let's call it capital K, and the other constraint. For example, in problem 188, so here K is a generic K, and in problem 121, K equals 1, and in problem 122, K can be regarded as positive infinity. In other words, no requirement on the allowed transaction numbers. So in problem 123, so K equals 2. In other words, there are at most 2 transactions allowed. So in problem 309, so here the K is positive infinity, and the constraint is the following. So we need to cool down 1 day to buy again. And in problem 714, so K equals positive infinity, and the constraint is to pay transaction fee, right? So these are the set of problems we are going to address. So now, actually, we want to comment. Once we solved problem 188, then we can readily solve all the others in the above list very easily. So here, let's look at problem 188. So we are not going to read through the whole problems, but we want to just look at the main statement. So we are given an integer array called prices, where prices I is the price of a given stock on the S day, and an integer K. Find the maximum profit we can achieve. So we may complete at most K transactions. So note that we may not engage in multiple transactions simultaneously. In other words, we must sell the stock before we can buy again. So that's the main statement. So now let's look at the analysis. So here, we are going to solve this set of problems using dynamic programming. So for this problem, we are going to explain using the following 4 steps. So first, step 1. So we are going to characterize the possible actions at each day we can take. So actually, we could choose to buy, sell, or do nothing at each specific day. So if so at a specific day, so if we have stock, so we could consider to sell or rest. Rest means do nothing. If we do not have stock on that day, so we could consider buy or rest. So for convenience of writing DP table later, so here we are going to use one indexing for the prices or days. For example, I day is corresponding to the index I-1 in prices. So this is just for convenience. So this is step 1. So in step 1, we specified the possible actions we could take. There are 3 in total, either buy or sell or do nothing, in other words, rest. So now with that said, let's look at step 2. So here, step 2 is DP interpretation and initialization. So essentially, we are using a 3-dimensional DP, but here the last index or the third index contains 2 states. I'm going to call it 0 and 1. So this is first. Let's look at the interpretation. So this is of fundamental importance. So first, TIK0. So here I means a day, and K means an allowed number of transactions. So 0 means at the end of that day we do not have stock. So 1 means we have stock. So for example, TIK0 means the maximum profit at the end of the SD with at most key transactions with no stock at hand after taking possible actions. So this is the interpretation for TIK0. For TIK1, so it means the maximal profit at the end of the SD with at most key transactions with stock at hand after taking possible actions. So with that said, we specified the interpretation of the DP table elements. So now let's look at the initialization. So actually the initialization is also not trivial or can be important. So we consider two cases. First, we have no stock, in other words, at day 0, right? Again, we are using a one indexing. So if we do not have stock, so then for any number of transactions, so here, in other words, no stock corresponding to I equals 0. So we haven't looked at the prices yet. So T0K0 equals 0, right? Because we have no stock, but we end at no stock, so this is 0. And T0K1 equals negative infinity means that we do not have stock, but we result having stock at hand. So here we set it to be negative infinity. So here this second can be understood like this. So as there is no stock, but 1 indicates we have stock. So here we can regard we had bought a very expensive stock from nothing. Here nothing means no stock. So this is the initialization for no stock situation. Another case is no transaction. In other words, K equals 0. So in this case, for any I, we have TI00 equals 0. Because we have no transaction and we have no end with no stock, so the profit is 0. And then TI01 is negative infinity. So here, because we have no transaction, but we result having stock, so we set it to be negative infinity. So here the latter can be understood like this. As no transaction, but 1 indicates we have stock at hand. So we can regard that we had bought a very expensive stock from no transaction. In other words, from nothing. So this is step 2. So we explained the DP interpretation and the initialization. So with that said, we can look at DP update rule. So that is step 3. So DP update or recursion relation. So at I state, so here I is bounded by 1 and bounded above by n. In other words, 1 indexing again. So let me emphasize again, I is greater than or equal to 1, not 0. Less than or equal to n, not n minus 1. Then the update for this day is the following. So TIK0, in other words, at the end of S day, we do not have stock. So there are two possibilities. One is that in the I minus 1 day, so we do not have stock, right? So we just rest at the I. So this is TI minus 1 K0 because no transaction happens. So this is K. And also, if at the I minus 1 day, so we have stock, then we can sell the price. We can sell the stock, right? So here, this first term, TI minus 1 K1 means we have stock at hand at day I minus 1. So we can sell the stock to gain this amount of profit. So in other words, the TIK0 is coming from two sources at day I, either rest or sell a stock. So this is the equation star. And then the TIK1 means that at the end of the S day, we have stock, and this is the maximal profit. So it actually is the maximal of the two terms. So the first term means that at I minus 1 day, we have stock. So at day I, we just rest. In other words, we do nothing. Or another possibility is that at I minus 1 day, we do not have stock, but at day I, we can buy a stock. So in this case, here K changed, because if we buy, so actually we use a new transaction happens. So here we write K minus 1. So in this case, up to day I minus 1, we allow at most K minus 1 transactions. So then we can, because we buy stock, we minus the price of the price and day I. So this is equation 2. In other words, the maximum profit at the end of day I with stock is the following. It's either from rest or from buying, right? So that's the DP update rule. So here let's emphasize again, a transaction is a buy-sell process. So notice that in the second atom in max function in double star, the index is K minus 1. So because new transaction happens when we buy, as we explained. So here is an emphasis. So finally, we just need to return T, let's see, N, right, TNK0. So here we, in order to maximize the profit, we must sell all the stock. So the final, after the final day, so we must have no stock in order to maximize the profit. So that's the 4 steps. So let's first review these 4 steps again. Then we can write the code. The reason we do the review is that we want to use this procedure to solve all the other problems in the list. So first, we look at the possible actions, and then we look at the DP interpretation and initialization. And thirdly, we do the DP update, and finally, we do the return. So with that said, let's look at the code. So actually now the writing the code is actually very routine. So here I'm going to use tabulation. So I'm going to first get the length of prices. In other words, how many days we have. So another detail is that I changed the little k in the function signature to be capital K, just to distinguish with the dummy with the running index little k in the DP table. So this is the one. And next we are going to initialize the DP table. So I'm going to call it a T, so which is 3-dimensional essentially. So here I'm going to do this. So 0 times, so because this has 2 states, right? So for a dummy index in range, so I'm going to use k plus 1, right? And then so this inside actually is this one, and this thing is k plus 1 times 2 grid or matrix. Then for I in range m plus 1. So in order to make to write it correctly, let's first check the dimension. So length of t naught, length of t naught naught. So let's do a check here. So for this problem, so we have k equals 4. So here this is 5. So we have 0 and 1. So we have 2. And here the length of the prices is 6. So we have 7. Everything is right. So now let's comment this out, or just delete this. And then we are going to do the initialization, right? The initialization. So for this, first I'm going to check the situation. There's no stock. In other words, at day 0. So for k in range and capital K plus 1, then we're going to set T0 k. If we do not have stock at the end of the day, so we're going to set it to be 0, right? If we have stock, so we're going to set it to be float, so negative infinity. So this is the one case. Another case about the initialization is no transactions. So in this case, we're going to set for each day. So for I in range m plus 1, then we're going to say Ti, so if no transaction is corresponds to k equals 0. So if we end with no stock, so we're going to set this to be 0. And then if we have stock, so I 0 1, and we're going to set it to be float and negative infinity. So up to now we finished the initialization. So next we are going to do dp update. So this is now routine after the above analysis, right? So for I in range, so we're going to start from 1 up to n. So we write n plus 1 here. So let's notice that we are using one indexing, or we interpret using one indexing for prices. Then we're going to iterate for k in range 1 to k plus 1, right? We end at capital K, the maximum number of allowed transactions. Then we're going to write the above two equations. First is tik 0. So this is going to be the max of two terms. One is ti minus 1 and k 0, means we rest at di. And another one is ti minus 1 and k 1. In other words, at previous day we have stock, now we sell it, so we get more money. So we add prices I minus 1. So here we write I minus 1 because here we are using one indexing. Another equation is I k 1. For this case, we're going to see I minus 1 and k, so 1. In other words, in the previous day we have stock, and in di we rest, and then we're going to write ti minus 1. Here we write k minus 1 and 0. So then we actually do a buy operation. So then we are going to spend this amount of money. So a point to notice is that here this is k minus 1. This is very important. So with that done, so actually we finished the dp update. So finally we are going to do the return. So this is actually routine. So we just return. Let me not track the indices. Let's write -1. So then we write k and we write 0. So this is the full solution to this problem. Actually the code is not very long as we understand the overall logic. So this kind of problem is sort of routine or standard. So now let's first do a check. Yeah, it passes one special example. So now let's look at the generic case. Yeah, it passes all the cases. Let's check again. Yeah, it should be very fast. So with that said, I guess that's the starting video for addressing this series of problems. Please follow up to see explanations for other problems in the above list. With that said, I guess that's it for this video. Thank you.